In this episode, Lethbridge Dhillon School of Business professor Dr. Sidney Shapiro asks, will generative AI change the world? Generative AI promises to transform industries and reshape our daily lives. From personalized recommendations to automated customer service, its influence will only grow as technology advances amid the current hype and craze. It's essential to understand generative AI capabilities, as well as the ethical, social, environmental, and practical challenges of this emerging technology. Dr. Shapiro's talk critically examines the impacts that generative AI might have on society, and how businesses and individuals can harness this technology responsibly.
Thank you very much. And I wanted to thank Dr. McMartin for asking me to do this, and the university. My normal speaking time is 3 hours long. I started creating slides when they asked me to do this, and naturally, I put everything I knew into the slides and ended up with 700. You're welcome. I hope you enjoy. So, today we're going to talk about AI, which is controversial and difficult. I gave a talk my first day at the university about AI, and I had 80 of my colleagues attend. I've never seen 80 professors in the same room before tonight, and it was kind of shocking to me because what are people worried about? Why would they come to my talk? And after the talk, people asked me, am I going to lose my job? Are universities going to be replaced by AI? What exactly is happening? And we kind of went on this trend from panic, the world is ending, to now we could live with AI, should we police it, and many other pieces. In the world of business, people are asking, how does this deliver value? Does this actually make sense for what we're trying to accomplish? And we're going to talk about that as well. But in case you were wondering about whether you are going to lose your job to AI, I created a quiz that you can take with your phone. Just take a picture of it. And it's basically going to tell you, based on the parameters inside of your job, if you're AI safe or not. There's 10 different levels, 16 questions, and a whole bunch of resources about AI as well. So as you go to the next screens, it will tell you about what's happening with AI, some of the background. And in case you find this talk boring, you could read through that information instead. It's possible. All right. So, I think one of the most challenging things, my graduate supervisor always said, the most difficult time to study something is when it's happening. And right now we're in the middle of it. And literally every week, and I actually use AI for real. Every time I go on LinkedIn, I get overwhelmed with, it's great, it's terrible, it's fantastic, a whole bunch of different things are happening. And I think it's really challenging to see what the difference is. I think I'm kind of like a realist. Does this technology actually make sense, as opposed to a believer, this technology is going to change the world? The title for the talk is AI is going to transform the world, because there's a lot of concerns about how does it actually work? Does it make sense? And that's what we'll be talking about, as opposed to cheerleading that this is fantastic. And in every industry, people kind of have this desperation, like everything is falling apart, what do we do next? And they're like, okay, it's fine, you know, as the place burns down around them. People are worried about losing their jobs. People are worried about privacy. People are worried about new technologies that have an enormous amount of data in them. In fact, all the collective knowledge that we've ever had, Wikipedia, our emails, literally everything, get shoved into this box, and then magic is supposed to come out. And that's really very, very challenging. Where does this data come from? How much data do we keep on producing to give it in order to come up with better answers? And of course, can that trend continue forever? So AI is not new. In fact, it's been around for a very long time in different forms. And we'll take a look at some of the different types of AI we've had in the past. For example, you may have heard of the Turing test. The Turing test is you're the tester, and you have to talk to the machine to judge if it's human or not. Are you talking to a real person? So for example, you could say, how do you like baseball? And then suddenly say, what do you think about pizza? A person can switch between conversations really quickly. Computers in the past had a problem doing that, and it might be really challenging to know, am I talking to a real person or not? That was like the level of, is this a real person? But now, using more advanced technology, you could definitely be confused that you might be thinking you're talking to a real person, but in fact, it's either AI or AI assisted. In the 60s and 70s, we had other pathways. Like for example, if my goal was to make $20, I could build an algorithm that would help decide, based on different options, how to quickly get to the answer. This is very important because we could build a stock market bot that would do things like buy stocks low, sell them high, and just repeat this expert system over and over again. right? So we could have a pathway to get to the answer. There's not a whole lot of understanding, but it does mean that if you do need to mow the lawn and you don't have a power motor, then it's going to switch over to some other branch, some other logic. This nested logic means that you can go through systems very quickly, and that was the system using punch cards. I'm very worried about giving this talk, so thank you all for accommodating me. So I went to Eliza from 1966, and I said, what do I do about stage fright? Now, Eliza's from 1966. There is no intelligence in this system, but it listens to what I say, and it uses reflective prompts to answer back. So it told me, have you asked such questions before? And I said, nope. And it said, all right, what do you do about stage fright? Tell me more. And I'm like, well, I'm doing this talk, and I'm very nervous about public speaking. And it says, did you come to me because you're doing a talk and you're very nervous about public speaking? Naturally, I say yes, and it says, all right, let's explore that some more. I said, sure. So it says, okay, so I'm doing a talk and I'm very nervous about public speaking. Tell me more about that. And it would just keep on going like this over and over and over again. At some point, it would probably ask me about my mother, and we could talk about that. You get the idea, right? It's going through a pattern, doesn't necessarily have any intelligence, but it's reflecting back whatever I'm saying. And that's kind of where we were for a very long time. So while we did have bots that sort of did understand kind of what you were saying based on what you put into it, it didn't really have any knowledge or other information it could add into the mix. In the 1980s and 1990s, we started shifting to new kinds of information processing, neural networks, the way that people's brains work, things that allow different pathways in order to make them work. Now, the idea is, imagine you have two choices. One of them is a less likely choice, one's a more likely choice. If you build that out in a huge system, you could start coming up with more obvious choices. So for example, let's say you had a pizza selector. Most people would order a particular topping most of the time. That's usually what happens. In Canada, those are plain pizzas, pepperoni pizzas. I'm hesitant to say Hawaiian pizza, but that is a thing. And the problem is that, please. So, and that's the thing, right? So you have these different types of pizzas that are more likely than any other possible pizza. This is very important because pizza, which we're eating, is a high-dimensional problem. And what that means is, if you think about the number of choices that you could order, in other words, how many possible sizes with any possible topping combinations can you make, there's literally millions of pizza choices, but yet most people order the same 3 choices no matter what, right? They walk in, they order one of those choices. If we know that, we could reinforce those branches to make those more likely options that happen. And as we'll see, this becomes more and more important because we're trying to prioritize information. You might have heard of Netflix. It's a thing that you could watch TV on your phone or computer or stuff like that. So Netflix offered $1 million prize, the Netflix prize, to prioritize information faster so that it could learn all about you and give you the kind of information you wanted. And they realized in the end that the enormous amount of processing to know everything that you've liked and everything you've ever watched and everybody like you and put that all together to come up with an answer is probably way more complicated than just giving you a random choice and saying, most people like this. Do you like this? And then it moves people into one of 20 archetypes. And we see the same thing happening in politics. We see the same thing happening in many other types of data sorting. We're prioritizing different branches of information. Now, this is not without controversy because we have people that say AI is the end of civilization. And you may have heard of Terminator, which basically a lot of people ask me about every single time I talk. The interesting thing is I'm talking about data sorting algorithms, and naturally people ask me about Skynet. You just gotta wait 1 hour, you can ask me as much as you want. But in popular culture, whether it's Silicon Valley or Dune or Atlas or many others, the bad guy is AI, right? It's seen as this world-ending, taking over, preventing us from hurting ourselves, etc. And this is a narrative that runs through society, and it's very common, but not necessarily real. And the question is, what are people actually talking about when they say AI? This is a critical distinction. Right now, we're in this part called artificial narrow intelligence. Computers basically do what we tell them to do, and quite often not very well. On the other end of the spectrum, we have artificial superintelligence or artificial general intelligence, where the computer thinks for itself, and it's like HAL from 2001: Space Odyssey, and it starts telling us, I'm sorry, sir, I can't do that. And that doesn't actually exist. That's science fiction, that's not real, right? So despite the fact that we have cool technologies, they don't actually bridge the gap between what we tell them and start coming up with brand new patterns. Essentially, and this is the recurring theme, ironically, of everything I'm going to tell you tonight, AI is recycling. AI, generative AI particularly, means that we're going to be using information the computer already knows to mix it up into new patterns. One of my students asked me, so what's the point of learning anything? Why should I be in school if generative AI can do everything that I can do better? They actually said that. So I said, like, I appreciate where you're coming from, and AI can do some cool tricks, but the real question is, can AI do everything better than you can do? It's a song. I don't know. I mean, I hesitate to say that that's the main difference, the key difference, is that you can think. You can come up with brand new patterns that you've been thinking about using the information from your entire life. And that experience and that information can form new patterns that previously weren't thought about. It's not remixing some other pattern that's already known, and it's not recycling information that other people know about. It's something brand new that's never existed before. And you have the ability to do that. Think critically about things. And essentially, as a university, that's what we do. It's all about critical thinking. It's about bringing information together, right? Bringing information that you would not expect. And like many of you, I've spent a very, very long time in university. I'm embarrassed to tell you how long, but a long time. And if I think about it, all the really interesting things that I ever learned in university were not from a class that I could have read in the textbook and the professor was talking about whatever. It was from the side things the professor said, those like just random things they said in class that really stuck with me and I think about all the time and I remember, and that builds into my experience, right? And that extra pieces, as they come together, build new and unexpected pathways that are really interesting and bring pieces together. Now, we are in a Cold War, an arms race of AI. And I'll give you a really common everyday example. I have this amazing job called an AI prompt writer, and I'm going to apply for it. So I take my resume and I put it into AI and I say, remake my resume in order to match this job posting. Now what happens is they put that resume into an ATS system, or applicant tracking system, essentially another AI, that also reads that resume and says, wow, there's a 90% similarity between this person's resume and the job. They must be great for the job. It sorts them according to people who rank highly and people who don't, and it offers the job to the right person, or at that point, maybe the person goes and meets a real human, the manager. The problem with this whole system is every single person is doing the same thing. So the hiring manager ends up with 20,000 resumes, which are all perfect, and the people applying are constantly getting rejected by the ATS system because they can't get through. Their resume is too perfect. So we have this big conflict. How is it possible that we could make the two of them match? What's happening? Now, if you extrapolate this and scale it up, you end up having an enormous amount of everything's AI, so it has to be perfect, and we don't get anywhere. In fact, on LinkedIn, hiring managers started writing, please don't send your resume, just send me a message, and I'll meet with you, and then I'll decide if you should send your resume. Now, if you think about this in every other field, it means that we have a glut of information. In other words, like a new era of spam. You know, at the beginning of email, spam was very exciting. This guy who's a prince is also emailing me and super excited to give me money. How did I get so lucky? And essentially, we're ending up in the same place because as we see AI-generated content, you start to say, that's not so great. Maybe that's not the right thing, right? And that also happens in large systems as AI programmatically can produce enormous amounts of content. So I think the problem is that as we start having more and more AI-generated content that is not real, eventually we start filtering it out. And that's really kind of the issue, that it's not quality of content, it's just more and more garbage. But AI is amazing. Don't let me tell you it's not. The greatest thing about AI is that it's super, super simple. There's no instructions. There's nothing to know. You just start typing literally anything in, and let me show you what happens. It's amazing. Like, you could type in literally whatever you want, cat eating spaghetti in dreamscape, colorful, whatever, magic happens. And that's amazing, right? That's stuff that people absolutely can't believe. Look, the cat's eating spaghetti. It's crazy. I know. I could have made a picture of spaghetti eating a cat, but I figured that would be offensive. So I decided to go for the safe choice. Thank you. So, and you could use this in so many different ways. Like, again, not to be offensive, I asked for a picture of an eggplant. I mean, who really is to say what an eggplant is? That's really the issue. So whether the eggplant is on the right or left, whether the eggplant is a combination of the different pieces of data the system has inside of it, still magic. Now, you may have or may not know what this is. This is called an automat. And in the 30s, like 100 years ago, this was a really, really big deal. Because you walk into this room full of these little boxes, you drop money in, and like magic, your food shows up. It was a huge deal. You put nickels in the slot, you press the thing, food comes out. And people were like, this is amazing. Arthur Clarke says any sufficiently advanced technology is indistinguishable from magic because people had never seen or heard or even conceived of an idea like this before. A slot that delivers food, ironically somewhat like Star Trek. But behind the magic, there is a real process that makes this actually possible. There's a person putting the food in there who takes your nickel and gives you your pie. It's not magic, there is really truth. So I hope you can get some of this, maybe looking behind the curtain tonight, and learn about some of the pieces that build AI and give you a better idea of how to utilize it. So let's first start with what powers AI. AI is powered by data. That's the engine that makes it work. Enormous amounts of data. Not only those different individual pieces of data, but the combination or the weights inside of them. Like we said, you could go to a pizza place and order pizza, which is again a high-dimensional problem. You might walk into a pizza place and think for hours and hours about the tens of thousands of possibilities that you could order, millions of possibilities. But the reality is you walk in and pick one choice and walk out. That's usually what happens. So, what is the connection? What are the strongest preferences, the strongest weights inside this material, and how should they be linked together? So for example, if I ask an AI model to tell me something about a particular topic, what's the most likely option that's going to come out? The challenge is that we don't necessarily know, but AI models are trained on the connections or the weights between words, how they're associated, what ideas go together, and what makes sense. These are called frontier models. Frontier models are made by the biggest companies in the world, and they use the most data. So for example, ChatGPT or Google or Microsoft or other companies like them vacuum up every single piece of publicly available data. In other words, all data, all of Wikipedia, all of everything they could find. In fact, many of the sites that people use, like Facebook or Reddit, sell people's data into these companies to create even larger and better models, to find out additional connections they may not have known about, right? So for example, I have a car that's very esoteric, a 1966 Charger, and I could go to Google and see if anybody's ever written about how do you change the carburetor, or it knows that the words 66, Charger, and carburetor go together, and if they do, this is what should come out. That sounds like it should work, but it's hard to do with all human knowledge. That's kind of the idea behind what AI companies are trying to do. And in this world of massive models from frontier models, by the way, these frontier models can cost $100 million to train, which basically means look for all the words and find out how they're connected. It means that there's a very big difference between what we can do on our computer and what they can offer, right? The massive computers that are running it. In fact, this is one of the times where academia has access to very, very little of this technology because it's so new and expensive. And AI models know about everything. They know about penguins. And we'll talk more about penguins later, but they really know everything. All human knowledge is shoved into this box, and we look at the connections. The problem is, what happens when you get to the end? So we have all knowledge. It's all connected to each other. We could find patterns. If I say, give me a recipe that has these ingredients in it, it can tell me. If I take a picture and say, here's a picture of what's in my fridge, can you tell me what that is? It works too. The challenge is that at some point we run out of data. There's just not enough of it out there. So it starts to create something called synthetic data. Synthetic data is made-up data that follows the same patterns. The problem is that the real world is not organized or ordered like simulated AI data. In fact, the real world is messy. And I'll tell you something really strange about my job. I teach students really cool things, like how to take data and build programs and make things happen. But in the real world, 80% of data is in terrible shape and has to be fixed, and people use Excel, and it is not exciting. I deal with the 5% at the very end when they go and they're like, man, I gotta clean the data and fix it and gather it first. And that's kind of the same idea. We have enormous amounts of data, but it just doesn't exist, or it's not very good, or it doesn't connect in a meaningful way. And if the new suggestions are based on these poor choices or this poor data, the results are going to be terrible too. And that's kind of the big problem. How do we connect data in a way that makes sense? So people build AI, and they put it together, and people are worried about Terminators taking over and flying cars and time machines. I've heard all of this at talks. But yet, sometimes they don't work very well. They don't work as paradigm-shifting AI. Sometimes they just misidentify cats. Another big problem is that there's this thing called a wrapper. People use an application programming interface, or an API, to connect to these big models like ChatGPT, start a company, plug AI into their program, and say, look, AI company and software. Some of them are getting millions of dollars in funding. But underneath, they're just ChatGPT, or Google, or something else. If you use somebody else's product inside of your product, that's generally a terrible idea. Now, imagine you were baking apple pies and you're selling them using a particular farm's apples, and they run out of apples, no problem, you could switch to another one. There's only like 3 or 4 companies in the whole world building frontier models that can support your company. At some point, for some reason, they can't serve you anymore, then you're out of business. So it creates a very risky proposition when you're building in, or as the major feature of your program, someone else's technology. Of course, spending $100 million to train your own model is difficult, complicated, and expensive. Most people aren't doing that. So we really create this problem that we have major companies that are building or supporting all the minor companies underneath them. Now, AI is magical, and it seems like the computer is just creating information on its own. Information is data that's massaged into a certain way to tell us new patterns. The reality, though, is that we have offices of people around the world who are actually doing labor in order to give you better results on your AI. Tens of thousands of people who are being exploited at very little money in order to build AI and improve the results. You may have noticed that AI, if you ask it a question, it brings you back an unexpected pattern, maybe hyperbole, maybe a different way of using English, because not everybody using it is in North America. And this is a huge problem because there is a massive human cost to the labor that goes into building AI systems. An interesting thing about AI is that companies feel FOMO. They're worried about being left behind. They want to adopt AI, and they're not sure where to start. As a result, every company is looking into AI. They talk about it. They're investing in it. Very few companies are adopting it. I always talk about this idea of like unplugging a piece and plugging something else in. And when I talk to businesses, some of them are saying, you know what we should do? Let's get rid of our accountant. We're just going to use ChatGPT. Yeah. It's going to save us a huge amount of money. And what we're going to do is we're just going to take our books, send it to ChatGPT, say, bring us back answers, and it's probably going to work okay until it doesn't, and it's really, really, really terrible. And that's the problem, right? We're not really sure what parts you can unplug, and more importantly, will AI work the way it's supposed to long term? Now, the problem is that AI trends, things are shifting constantly all the time. There's a new invention, a new twist, and companies are like, let's pivot, let's try this new technology. It's a really big problem. So many companies have developed AI, but only 22% have moved beyond AI proof of concepts. This is really important because most companies are not actually changing enough. They're just looking into the technology to see what it does. But only 4% of companies are generating value/revenue from AI, right? So think about it. You have this technology. Now, I should tell you, in fairness, that this is the first semester I let my students use AI. My class policy says, use it as much as you want, knock yourself out. Use it, but you will be judged on the quality of your work product. And I still have a 70 average in my class. So what's happening? How is it possible that using AI, you don't actually have perfect grades all the time and flying cars and so on? And the issue is that underneath that learning process, you actually have to have real knowledge, like to say, is this good or not? And if you don't have that knowledge, then you could copy-paste really well over and over again with a shallow type of learning, but you don't actually fundamentally understand if this is good or not. And that's really critical, especially for a business that has to generate value and revenue from whatever it's building. And if you just look at something that's like good enough, will your customers think it's good enough? Are they going to be happy with this? We'll look at some examples, but I'm not sure. Stanford has a report that talks about the state of AI in 2024 and what's happening. Like AI is better than humans at some tasks, and industry is building AI rather than academia. Frontier models are so expensive they're impossible to compete with. They cost $100 million to build. Certain places, like in the United States, is ahead of everyone else, especially because there's no regulation. So unlike in Europe, where they started regulating AI and looking at, is this always a good idea? The US, you can build whatever you want. As a result, there's a lot of money being put into it. There's no way to compare AI to other AIs, and this is a big challenge. I have a programmable TV in my kitchen, and I sat and I asked ChatGPT, how do I program my TV? We went back and forth over and over again for 3 hours, and it was not telling me the answer. In fact, I got stuck in this loop where it was just telling me to type things in, and I felt like I was really close, but it wasn't happening, and I know how to program. So I said, okay, never mind. I just took all the text, like hundreds of pages of chat with me and ChatGPT, and I pasted it into a Google AI engine, and it came back and said, type these 3 words in, and it worked. Because they're not trained on the same data. They don't have the same weights or model inside the model. And there's really no way to compare what each one has because they have trillions of data points inside of them. But a lot of people are investing in generative AI, and there's tons of startups. I'm currently a mentor for a contest at Western University to build out AI in education, the next app. But what I'm getting back aren't sound business ideas, they're cool technology ideas, which might be unsustainable or not make sense. One of my students developed a cool idea based on technology. You could tell me what you think. It's an app where you could find children and find babysitters and put them together to find babysitters for your kids. Theoretically a great idea until you think about it, it might be a kidnapping app. So probably not the best idea to put those things together. They're sort of a balance, right? And that's why going back to fundamentals and saying, like, do you have a lean canvas for this idea? Does it actually make financial sense to run it? What are you trying to do? My last point on this is that Google has a startup fund that they'll give your startup $250,000 in cloud credits to build out your idea. Amazing. What happens after that money runs out? You give AI companies money forever, right? And that's the problem. The problem is that it's very expensive to run, but may not generate a lot of value. The data in AI makes workers more productive and leads to higher quality work. Scientific advances have somewhat accelerated. That's debatable because there's also a lot of problems. And the number of AI regulations has slightly increased, but I think there's still a lot of problems. We're starting to talk a lot about AI agents. AI agents are the idea that we could get an AI, instead of just talking to it and getting back an answer, but to do things for us, like a robot that's going to go out and do jobs and multi-stage processes. Now, we're up at the top in this massive hype cycle of generative AI, but we're finding that although there's cases where it works really well, there's cases where it doesn't work. To give you an example of this, people are using it for text, generating code, images, and video, and despite the fact that it says 2023, we're not able to do a lot of these things. For example, wouldn't it be cool if you watched a movie and you're like, you know what, I'm not feeling Matt Damon in this movie, I was gonna switch him for a totally different actor, just remake the movie for me, right? Or like, I don't like Drake in this song, change it to Madonna, right? Like, that's theoretically possible, but the problem is that although we have this amazing acceleration in software, we don't yet have AI chips and hardware that could actually do that. As a result, we know that these things might be possible if we had 1,000 times faster computers and more power, and those are really serious issues because those computers don't exist. So a lot of these things, you know, in the 60s when we had Star Trek, we saw, wow, talking to a computer might be possible one day. It's possible today. The question is, how do we scale up? And we scale up with much, much bigger computers. The question comes down to, where's the value? Like, does it actually make sense? How much water and power did it cost me to make a picture of a cat eating spaghetti, right? In AI, we're moving between expert systems and machine learning, which we give the computer more explicit instructions, to more natural language, where we're telling the computer what we want to do, and it follows a pathway and instructions on how to do it. And all of this is because of transformers, not those, different kind. But the idea is that transformers connect different words or ideas together. I'll show you an example. At the bottom of the slide, it says, John wants his bank to cash the. You could probably even complete the sentence, but what do those words mean? John could mean toilet, and bank could mean river bank or financial institution. Cash could mean a bunch of different things. Each transformer will pass the information from one level to the next, and we'll try to figure out what does it mean by each one. Now you'll notice in red, where it says wants is a verb, cash is a verb, think of it like puzzle pieces, that at each stage you're trying to put them together. Now, GPT-4, like ChatGPT-4 or 4.0, has 120 layers of these transformers that's trying to piece together all these sentences. In fact, when you ask ChatGPT-3 to answer a question or generate a sentence or come up with a poem, it can go through 13,000 different possibilities at each layer, creating exponentially massive amounts of data, right? So again, imagine you went to a pizza place and you said, what's good? The person doesn't think about it, they just tell you, order a pepperoni pizza. It takes 1 second. Imagine that person had to think about tens or hundreds of millions of combinations and then get back to you. That would take a lot of processing. Now, as the computer is thinking about these things, The computer doesn't have consciousness or emotions or subjectivity. It's basically just following preset patterns. And although it seems like somebody's talking to you, they're really not. It's all based on statistics and algebra and computation, but huge, because it's using an enormous amount of processing power to find the answers and bring them back to you. Now, I made a scenario to show you to talk about this idea and maybe illustrate the point. It wasn't good enough, so I got rid of that and I came up with a better one, and I thought about that one, and I came up with the most Canadian scenario I could possibly imagine. You're welcome. So this is an RCMP officer driving his horse through a Tim Hortons, and he shows up at the window and says, "Good morning. Welcome to the Roast Ham Tim Hortons. What can I get for you?" The Mountie says, "Good morning. Could I get a large black coffee?" The attendant says, "Absolutely." The Mountie says, "Do you have an apple for my horse Betsy?" The attendant says, "Apple? Let me check." "Sure thing. Here's your total," etc. Now, I know this is a very, very specific hyper-Canadian scenario, but you've probably had a similar interaction at Tim Hortons before. In other words, you went to Tim Hortons, you walked in, you said double double, "Thank you please." They gave you a cup and you walked out. I'm positive everyone in this room has had this experience. More importantly, when you went into that Tim Hortons, you didn't think about it. It just happened. And every time you go into Tim Hortons, your brain on automatic just does these things. It's following a pattern. The person behind the counter says, "Please and thank you, here's your change," etc. Right? Now, if we think about why you said the words that you said and the pattern that you said them, actually, each one of these words that's on the screen is a token. All of these words on the side that are in color are actually numbered, and they're like fridge magnets in a certain order, and they always follow a certain predictable pattern. Of course, you could walk into Tim Hortons and say absolutely anything. I encourage you not to do that, but if you do, anything could possibly happen, but more often than not, you're going to follow a particular pattern that you're always going to follow. I've been to Tim Hortons 1,000 times, I've always said the same words. You probably have too, right? Now, if we know the order of these patterns, we could start to make most likely Tim Hortons conversations based on numbers. In other words, we have these patterns. Now, the real question is, does everybody follow the same pattern? Is your order the same as mine? And of course there's not, and of course people have different patterns. Some people say, "I love getting coffee from Tim Hortons every morning," and some people say, "Coffee from Tim Hortons every morning I love." But beyond that, there's not that many other patterns. There's not millions of them, right? There are patterns that follow predictable orders. And because of that, if we look at all language and all information that's out there and compare all those words, we start to get an idea of how those patterns are formed. Or sometimes we just make them up randomly, right? You know, there's no connection between them. And this brings me to probably my most important question. What makes the great novel? You know, you sit there, you're writing, what makes the great Canadian novel? Is there a pattern inside that book? Probably not. Actually, most books that you pick up might have a different internal pattern than every other pattern. In fact, that's what makes them special and unique and different, because they are different, right? Maybe Tom Clancy books are all the same, but you get the idea, right? John Ludlam, they're all the same. But you know, most books are different than each other. That's what makes them interesting. They don't have a predictable set pattern. But students at the university gave this a test, and I'm going to ask you the most controversial question tonight. Is Die Hard a Christmas movie? Please, please, please. My boss is here. You got to... All right. So I went to the AI, and I said, what's the recipe? Just like we talked about the great novel, what's the recipe for the best Christmas movie ever? So we mixed in Home Alone. On top of that, we put in Die Hard, obviously. And then on top of that, we mixed in Miracle on 34th Street and Elf, right? Every best Christmas movie, threw them together, and this is what we got. So, does it make sense that you could layer these ideas on top of each other, and just by throwing in random ingredients, what's going to come out is the best Christmas movie of all time? I don't know. I'm not really sure what this movie is about, but it's certainly not the best. It's not a factor of creating more combines into the best. It just makes it gross, right? Just like if you took every ingredient in your kitchen and combined them, it probably wouldn't be more tasty, it would be terrible. How does it work? People use LLMs. You type in something into ChatGPT or a different AI. It has things like user input. It looks at patterns and edge cases, which are extreme examples that are outliers. It feeds it into the AI, and it goes in this pattern. It loops back and forth over and over and over again. It learns from what people are saying, and when I say learns, it means it's retrained on data that people put in to ask new questions. And here's an obvious question. How do you get cheese to stick to the top of the pizza? Somebody asked Google, and it said, obviously, use glue. It's non-toxic, it's safe to eat, it seems completely logical, and it's sticky. Now, Google said, okay, this is a problem. Clearly we don't have enough people asking really stupid questions to train our model in a way that it can learn every single possible thing. So we're going to create an oppositional AI called red teaming, and it's going to ask every question that people wouldn't to find things like sticky glue on pizza. Now the problem is that when you have an issue and you create a bigger problem to fix it, you start getting into the situation where it never ends, right? And you end up with this massive problem to fix another one. In other words, we have walnuts that we're trying to open, but instead we start building sledgehammers, and the sledgehammers scale and scale and scale until eventually we're not trying to solve or fix a problem anymore, we're trying to build a better sledgehammer. Walnuts don't necessarily change or get any bigger. So this is kind of the problem, that we have an exponential amount of money spent on fixing tools, but we don't necessarily have that in terms of the problem. Now, I should tell you, perhaps somewhat embarrassingly, something that professors love to say. And I know there's many professors in the room, so I'm a little hesitant to tell you this internal secret we have, but professors love telling students, find the gap in the literature. Read it all, and then find the missing piece. And there's a guy who said this, Mendeleev. In fact, if you see the periodic table here, it has a bunch of white squares. Those are different elements that they knew existed. They hypothesized they were there, but they couldn't prove it until much later when eventually they found out and they filled out the periodic table. Makes sense. Find the gap in the literature. Now, Meta, the people who make Facebook, decided to do just that. So what they did is they took 48 million scientific papers, they fed into a massive AI engine, and they said, find the gap. What are people not talking about? And we should research that. And it found a lot of extremely important scientific advances, such as people eating glass. There's been no papers written about people eating glass. There's tons of papers on human nutrition. There's lots of papers on glass, material sciences, etc. If we combine those, Nobel Prize in the making, we can make stuff happen. Or, another important topic, there are no papers about bears in space. Now we have tons of papers on bears and we have tons of papers on space, but nobody's ever thought to use these ideas together. Now, it turned out that was not a good idea and they shut it down after 2 days. Apparently, finding the gap in the literature based on the patterns in the literature itself doesn't create knowledge. Normally you create real knowledge and then you write about it, as opposed to the other way around. Otherwise, I could have read Harry Potter and I'd be playing Quidditch right now. Now, I'll tell you 10 important questions to evaluate the idea itself and the project. These are things that I ask all the time. You talk to a client. What specific business problem are you trying to solve? Is this a generative AI problem? What kind of data do you have? Because data is the engine that feeds the AI, and if you don't have enough of it or the right type, your project's not going to work. What are the expected outcomes, or how do you define success? What actually makes sense in this context? What constraints exist in terms of time, budget, and expertise? And how critical is explainability or transparency? AI is like a black box, and we're not sure why, of those 13,000 possible outcomes, it picked the one it picked. There is a technology called explainable AI, which is theoretical. The problem is, if you paid 13,000 times more to get the answer, in other words, to follow that pathway, it would be much, much more expensive. So instead, we're kind of saying, give us whatever you want. Just put some answers in there and just put them right back out. We don't know why. We're not sure what the competing arguments were. On the other hand, we have a systems question, like how much does this technology really cost? Students told me that AI costs $20 a month, but maybe it really costs $2,000 a month, but they're trying to get you to use it, so they're making it very cheap. Maybe if you built this in production and you're actually paying to use this on a server, it costs tens of thousands of dollars. And that could be a huge factor in terms of, is this a good idea? Can generative AI scale effectively with my business needs? In other words, it's great at doing things it knows how to do, like writing resumes or sending customers letters, but sometimes that works terribly. And again, I apologize, my boss is here, but a student wrote me a very long, very technical, very complicated 4-page long email, and I said, I don't have time for this. I took the entire email and I dumped it in ChatGPT. It wrote back all the answers and I put it back in. The student immediately responded and said, thank you so much, Professor. I appreciate your generosity. I'm like, oh no. This is when I get fired. This is bad. Now, the very last line of a 4-page email, the student said, I realize the semester's ended, but I'm still asking if I can have an extension anyways. The answer was obviously no, but ChatGPT wrote, of course you can, and I would definitely talk to the dean and sign a waiver on your behalf because you deserve handing in homework after the semester's done. Great. All right, so without a human in the loop of understanding how the technology actually works, we're giving away control to a system that may not be on the same page as what we actually want. If you look at this even further, building out agents that will autonomously go out and do things could create even more larger problems at scale. You know, with one student, this is manageable. At scale, it's a cascade failure that every single person I know emails me back simultaneously saying, wait, what are you doing? Extend the semester. Not good, right? Finally, as you're feeding AI into this system, it's learning from your data, it's rebuilding it into the system. Is that a good thing? Right? Does that actually, the next time you generate something, new information is going to come out that's going to be even worse? Now, there's a good example of this being used by Klarna. Klarna is a financial services company, and they basically took 700 people's work and they gave it to AI. It can answer calls. It reduces time from 11 minutes to 2 minutes. I've never called Air Canada or Klarna or anybody else, and ever it helped me in a way that I didn't have to talk to a person. The challenge is that it follows predictable patterns, great, but it doesn't work in unexpected cases. It's also really, really expensive, right? You have to spend a lot of money to get AI to work because you don't have scale of economy. One of my colleagues worked for a consulting company 30 years ago, built an Excel sheet, and they're still using it today. So that company has 30 years of Excel use from one unit of work. Generative AI means that every single day for 30 years, you'd be creating additional units of work in order to get to the same solution. Like Excel you could use over and over again for free, generative AI cannot. It has to rerun from the beginning, causing a huge amount of more time and money. Now, I thought I would tell you some of these non-sensationalized headlines about AI, what people are talking about. We can discuss it. Things like Google and MIT are offering a no-cost AI course for educators, trying to bring AI to the masses. AI-generated food looks better and tastier than real ones. Alberta workforce is concerned about the impacts of artificial intelligence. AI Fukushima is inevitable. Can a fluffy robot really replace a cat or a dog? My weird emotional week with an AI pet. And conservationists turn to AI battle to save red squirrels. Nearly all Gen Z AI workers admit to using AI, but most Gen Zers are terrified of AI taking their jobs, and their bosses consider themselves immune. Canadian companies are excited about AI but slow to adopt, and Canadian AI companies should be thinking about using AI to rethink traditional hierarchies and empower every employee. Now, I love this. Salesforce hired 1,000 real humans to sell their AI sales agent to companies, and this one slide tells you everything you have to know, right? I mean, why can't the AI sales bot sell itself to people? What do you need the 1,000 people for? Clearly, there's some gaps here. Can AI take teaching out of the Victorian age? Can AI transform the classroom just like the calculator? How to stop generative AI from destroying the internet? ChatGPT may lead to the downfall of education and critical thinking. AI cheating is hopelessly irreparable, corrupting the US higher education system. No, AI won't destroy education, but we should still be skeptical. This is the first year of AI college, ends in ruin. Will AI replace human TAs? Which is a good question. Boston University says that maybe they'll replace striking grad students with AI. But then they said, no, actually we wouldn't do that. We're never going to replace people with AI. AI is already taking jobs, and routine tasks are the first to go. And depending on what your job is, there are a number of jobs that can be automated more easily than others. Certain things like banking and insurance, certain processes can be automated really easily. And naturally, people wonder, what about other jobs? Like, how do they work? And it really depends on the level of automation. It depends on what people do every day. And if there's a process that makes sense to use AI. Clearly, replacing an accountant or a doctor wholesale with AI not only doesn't make sense, could lead to very risky or wrong outcomes. George Carlin's estate sued an AI company for making deepfakes, AI that, recordings that he never actually did. And Hollywood had this massive ongoing AI strike, and there was a huge amount of pushback against it. The same thing's happening with driverless cars. So we see many different areas where this is happening. Now, people are worried, what happens if the whole economy begins to shift? In other words, there's new AI that's going to take over jobs, and we have to start training or retraining using AI in different ways. I think AI is a tool that we can use in different ways and leverage it to help us in doing the jobs that we're already doing, or find new jobs that work with AI economy. But I don't think it represents the massive shift, at least right away, in terms of how does it work? Right now, AI is very expensive to use for the most part. Because AI images are getting better and better, it could mean that identifying deepfakes, just like spam, becomes more challenging too. And that could be a really big issue. Now, the real question is, what can go wrong? One of the problems is that AI creates faded copies. The more you're recycling and putting into it, you're not coming out with unique original ideas, you're just recycling old ones. That's kind of a challenge. AI costs an enormous amount of money to the companies that are building it. In fact, hidden secret, all those companies are losing money to bring you AI, which means there must be something in it for them. They want the world to shift into an AI-friendly world before they could actually start making some of that money back. And that creates a really big challenge because they're maybe not aligned with the people that are using it. And AI is ruinous for the environment, so much so that it costs an enormous amount of power and resources to use AI. Now, Bill Gates has an idea that he's going to build nuclear power plants to serve the AI demands of the future. Now, what does the future look like? So we know that AI right now at scale may not make sense, but there are a number of ways that we could look at AI and think about possibilities. One of them is AI on small chips. Right now, AI is massive and it sits in huge data centers. But it is possible to have a small model that does specific things. Like, for example, instead of knowing everything about penguins, which most frontier models do, instead we have AI models that know about potatoes. So you put your potato in the microwave and you say, AI microwave potato, and it says, okay, 6 minutes, and it puts it in there and it cooks it, right? Something that if your AI model only knew foods and how long to put them in for, it would be millions of times smaller than the massive AI models that know all of human knowledge, which is probably a good thing. You could even have an AI model that's complex and say things like, I put these 3 ingredients in, how long should I microwave those for? And it understands the weights between them, which means that it could have some kind of connection between the data, but you don't need all data. Now, those chips that AI works on in your microwave don't exist yet. That's why we don't have AI in our phones that doesn't run on a data center. We don't have AI in cars, but it will happen eventually that we'll have language models that speak English or a different language inside of our phones, and they actually work at scale. In Alberta, there was an article that came out recently that was talking about AI note-taking. And across the province, across the country, you can go and talk to your doctor. The whole conversation is transcribed. That goes into their notes. The doctor looks it over, signs off on it, and it's much more efficient. The problem is, what happens if something goes wrong? Now, there are many different ways to look at this, including some of them that use very objective information. Like, for example, taking a look at slides, you could say, is this cancer or not cancer? These green lines that are on the slides are from a project called Google Microscope, where it has millions of examples of slides and then uses it to create those lines, to look at the slide and suggest to the person what it thinks they're looking at. The really important thing to understand is that if you have millions of slides of cancer or not cancer, you could train a machine learning algorithm to detect if it fits into group A or group B. That's called supervised learning. The challenge is that if it's based on words and their association, I might be completely sarcastic, and my patterns follow completely differently than everyone else. As a result, what makes sense for one person may not make sense for another. If I go to Boston and I start saying wicked, that's actually a good thing instead of a really bad thing. Wicked's a thing right now. 60% of Americans say they'll be uncomfortable with providers automatically using AI. The challenge is that it's not always explicit. Sometimes AI happens implicitly underneath the systems they're already using, like, for example, in electronic medical records. So we have 10 minutes, and I'll tell you about some of the research and the questions I've been thinking about, some of the things that we've been working on in the lab, and some of the big ideas that we've had around AI, either in 2 flavors. One is an object of research. In other words, at some point in every discipline, somebody wrote a paper that says, in geography, I asked AI for citations and it made them up. And in health, somebody did the same thing. The problem is that that's not really good research because AI model is constantly being retrained. So a week after that paper came out, AI was different and it learned from those mistakes, or at least built in new solutions. So there's AI as an object of research and AI as a methodology that can help you do other things. And you'll notice a combination of both of them. With some of my colleagues, I started working on a project where we fed in HR data, resumes and so on. And you can see those in the Excel sheet at the top. And we said to ChatGPT, what do these look like? In every row, every image is generated for the same employee over and over and over again, independently on a different system by itself, which means that every picture should be different and random. But instead you see that some rows, like the second, are 80% black women, which it should not be. Why did it do that? We hypothesize that this is implicit bias built into the model because we asked for things like openness, conscientiousness, extroversion, agreeableness, neuroticism, and political affiliation, which should not be tied to racial characteristics. And this is really surprising because it means that there's a hidden filter inside the model that prevents information or promotes it because old data that's been collected over a very long time suddenly is coming up in ways that we don't expect. With colleagues, we recently published a paper on information seeking. Parents ask, why is my kid crying? And they would ask Google. People stopped using Google and they started using ChatGPT, and ChatGPT sometimes said wrong answers. We printed out every possible AI model we could think of. We compared their answers using inter-rater reliability with actual experts, and we found that most of the time it was mostly right, but this is like a critical issue. You don't want the person to do the wrong thing, and that would be terrible with catastrophic outcomes. So we looked at how this shifts. In a system where you can't have any actual objective information, sometimes using this as an information-seeking gateway could be really terrible. We asked questions like thematic analysis. What does that even mean? You might have heard if you do qualitative research in thematic analysis that at some point you reach theoretical saturation. You can't think of any new ideas, but AI can generate any amount of new ideas. In fact, in the particular case that we did, my human colleague came up with 3 themes. AI came up with 103. And if we scale that and go back and forth, AI is going to come up with 10 million, and my human colleague will still have 3. Now, another paper we're working on is with Atlas TI. And Atlas TI says, we're going to take your code, if you use Atlas AI, send it to ChatGPT, but, and I'll read you the part here, you might not get the same results if you send it to AI, because AI is always making it up in a new way. And more importantly, that you could only research topics that we let you research. For example, you can't research hate, harassment, violence, self-harm, sexual, political, spam, deception, or malware. Now, those are important things for society to research. In fact, that's what researchers do. They research things that are topical and important to find out what's happening in society. If you're blocking all human knowledge because of AI, you end up gatekeeping what people are able to do. There's a huge debate between can we detect AI? If you want my personal opinion, the answer is no. I mean, it might be possible to, and there's tools. I think it introduces problems like equity. In other words, a student with a fancier AI that they're using to cheat is going to be caught less than the student with the less fancy one, and that's a big problem. You can't really know because sometimes I write human-generated content. I'm actually typing it on my computer, and I send it to a detection program, and it says 100% robot. I don't know, right? And I think this is a massive problem. Now, there are different engines that are saying, we're just going to record all the text, and you could just not check if it's AI based on patterns, but check if we actually generated it because we know all the things we generated, which creates huge privacy concerns as well. Yes, it is objective, but maybe not so much that you want to fail a student in a course. I think it's a very big challenge. With one of my colleagues, we're looking at AI in Alberta businesses, and we're talking about, is it possible to adopt AI? Are you at the AI stage? A lot of people are interested in it, but maybe they're really at the Excel stage, and they're just starting to put information into the computer. They're not actually ready to take advantage of very fancy tools. With the library, we worked on an AI story generator that during the month, I think it was June, generates 126 trillion different story possibilities. And you can go there for the entire month and see every 60 seconds a new story generate with completely new possibilities. A lot of the projects that we worked on, especially in projects this year with occupational health and safety, we looked at things by word translation like Google Translate and with block-based translation. This is really important because if you take each word by word, literally, and translate them, quite often it doesn't make sense at all. And what we did, here's an example. So I said, I'm feeling blue, I put that in, and I got literally, I am blue, in 3 different languages, which is probably not what the person intended. Possible though, the robot's blue. However, if you use AI block translation, it figures out what is the context for this sentence and comes back in a way that actually makes sense. In other projects, we're working on a project to look at gendered language. So we feed in large amounts of corporate documents. There's a very big difference between corporate documents written by lawyers and PR people. For example, imagine a bank. They have things like Happy Pride Week. The person who's writing that is in marketing. The person who's writing your mortgage papers is a lawyer. And if you look at all those documents in a large scale that are coming out of massive databases of corporate filings, you see a very large percentage that are written with gendered language. And we wanted to know, before we could even talk about how to fix it, How much is out there? How does it work? What are the different structures? What programs are corporations using to see the differences? And I think that this is a large-scale problem that can be solved easily with AI if we put the right pieces together. With one of my students, we recently published an AI framework in program evaluation where we said the 6 steps to start figuring out, should you use this in your company to figure out what's going on, comes with identifying patterns in data, predicting future outcomes, discovering areas for improvement inside of your data, providing visualizations that could be automatically created, automating data analysis, and building intuitive dashboards. And all these can be helped or automated, or even better, the AI can teach you how to do it through this process. Now, coming up in the next semester, we're doing a study looking at how temperature or variability inside of AI changes the outputs. When we found that the more creative you ask it to be and the less stable it is, it starts to come up with many answers that are all over the place, meaning they're much, much less reliable. This is a really big problem because as we're asking questions that could change the internal temperature, at scale, it could lead to wrong answers in a very large way. This year I have a podcast, and I've been talking, I never did a podcast before. The research office called me and said, you have a grant that you should use, make the podcast. I'm like, all right. So I started making the podcast. It's called AI in Action, and all the guests have all had this fascinating story, but more important than the individual stories, the big picture is we all live in this moment. 2 years ago, there was no AI. Right now, we're surrounded by it. What's happened? How do we see our work, and how do we see ourselves? For students, I think this is fascinating because I had to write my entire dissertation myself, sitting in front of the computer every single day, grinding out word after word after word. I even joined a site where you sit in silence with another person on the camera to continue typing to be motivated, and eventually, thankfully, I graduated. But now it's like a completely different world. Content is different. The way students interact with content is different. I went into my professor's office and he said, read a book and come back to me. And now it's like, ask ChatGPT. It'll just explain to you, just tell you. I'm like, that's amazing. So the point of this story is nobody has ever read my dissertation. But I figured, come on, with AI, we could probably fix this. My dissertation is like 400 pages. So I took it and I put it into AI and I built a different podcast called The Hidden Influencers. My PhD is about hidden influencers inside of large systems. So what I did is I took all the content, I said, write it in a story, fun way. It created the audio, it created all the different pieces, and it built 20 episodes. I'd never listened to it. I don't know if it's any good. But it has pizza pictures in it, and it just all built it out automatically. Now, we started off with this fundamental question, will generative AI change the world? I think that it's going to impact the world through automation. Workflows are going to change the way that we do things, and there'll be a lot more innovation coming out of AI. I think it's going to reshape business, education, and entertainment. My job used to be that I come to class and people watch me type, that's how they learn. But now I could ask them what they think, generate a bunch of ideas, and we can explore them together. I think that's really beneficial and helpful. And it doesn't mean that they're not getting higher than a 70. They still have to go out and read the book and actually learn how to do things. But generative AI is changing the world. But we have to be aware of like the ethical, social, and regulatory challenges that come with it. So my takeaway from tonight is simple. You can think, create new patterns with your brain, and leverage AI to do things because it's a tool that you could use like anything else. Thank you.
In the next episode, Lethbridge political scientist Dr. Lars Hallström helps us understand political and policy innovation in Alberta.